Welcome to The Explainer. Today we're looking at something that honestly sounds like pure science fiction. We're talking about how an AI read a simple, one-page essay and then, with no human help at all, built a working time machine. Now, it's not for traveling through time, but it is for seeing into the future of our digital world.
Okay, so let's start with something we all just totally take for granted. You glance at your phone, your laptop, your car, and they all know exactly what time it is. Our entire digital life runs on this silent, shared agreement about time.
But what if that agreement just broke? This isn't just some thought experiment. It is a real, ticking clock. There are specific dates that are hard-coded into our digital infrastructure. Dates when some of the fundamental systems we rely on are literally programmed to fail.
A lot of us remember the panic around the Y2K bug, right? Well, think of that as just a dress rehearsal, because there are two similar and potentially way more disruptive events looming on the horizon. One's coming in 2036, and another one is right on its heels in 2038.
And you know, this isn't some fringe theory we're talking about. One of the actual architects of the internet, Vint Cerf, recently published an essay sounding the alarm on these exact issues.
In this short, really direct essay, Cerf lays out what he calls a predictable and therefore preventable hazard. It's basically a ticking time bomb hiding in plain sight inside countless computer systems all over the world.
And he poses this very direct question. This idea of wrapping around, that's the heart of the problem. You know, it's kind of like the odometer on an old car, hitting 99,999 and then just flipping back to all zeros. Except here, we're not talking about miles. We're talking about time itself.
So, let's break this down a bit, because there are actually two separate issues. First, you've got the 2036 problem, which affects the Network Time Protocol, or NTP. Its counter just runs out of numbers and resets to zero. Suddenly, systems think it's the year 1900 again. Then, you've got the 2038 Unix problem. Its counter can hold both positive and negative numbers, so when it runs out of all the positive ones, it flips over to become a massive negative number, sending the system's clock all the way back to 1901. Both scenarios are, well, catastrophic for anything that needs to know the correct date, from medical devices to the Internet of Things.
So Vint Cerf's essay is a really crucial warning. But what if we could do more than just read his words? I mean, what if we could actually bring that warning to life and watch the whole thing unfold?
This is where things get really, really interesting. An AI tool called DBbun did something pretty amazing. It read SARS essay, just the PDF, and with no human intervention, it automatically wrote the code for a working simulator of the exact problems he was describing. It literally turned prose into a functioning program.
The process itself is as elegant as it is powerful. So first, the AI just reads the document, the raw text. Then, it goes through and identifies and pulls out all the critical information. You know, the numbers, the dates, the technical terms. And finally, it uses all those little extracted pieces to build a working model completely from scratch.
And check out how specific this is. The AI isn't just getting the general vibe of the essay, it is pulling out hard data. It sees Jan 1, 1900 in a sentence and knows, okay, that's the NTP start year. It reads Feb 6, 2036 and tags that as the wraparound event. This becomes the raw material for the entire simulation.
So what's the big deal? Well, the crucial point is this. We've gone from a static warning on a page to a dynamic, interactive tool. This simulator lets us see the exact consequences of what Vint Cerf was describing with our own eyes.
Don't get me wrong, the original paper is fantastic. It describes the overflow events using words, and that's powerful. But it's still an abstract concept, right? Something you have to imagine in your head.
But this graph, this just shows the difference perfectly. The simulator actually plots the time counter. That green line, that's a modern 64-bit system, humming along just fine. But look at the solid blue line. That's the old 32-bit system, and right at 2036, it doesn't just stutter, it completely falls off a cliff, resetting back to zero. You're not just reading about the problem anymore, you are seeing it happen. And that drop, that's a jump of almost 4.3 billion seconds into the past, an instantaneous 136-year leap backward in time for any computer that's affected. Just imagine that.
And because it's a simulator, it becomes an active tool. Engineers can now ask, what if? What if we patch 20% of old devices per year? What if we only manage to patch 5%? The simulator can generate the data, plot the risks, and create real reports that help people in charge actually measure the problem and plan a response.
So let's zoom out to the bigger picture here, because this really hints at a whole new way of interacting with science and research itself.
This quote from the project's own documentation just nails it. The technology transforms a static description into a quantitative decision support tool. It makes the research actionable.
And this one example opens up such a fascinating possibility. What if reading a research paper was just the beginning? I mean, just think about it. Imagine reading a climate change study and being able to tweak the carbon emission variables yourself. Or an economics paper where you could actually run your own models based on its findings. Or a medical trial that you could simulate. The potential here is to transform static words on a page into living, breathing worlds that we can actually interact with and learn from. And that is our explainer for today.